React components and JSX work a little different than ReScript, and in this video I hope to clarify certain things that confused me when I started my ReScript journey. Let's dive in. First, I'd like to remind everyone what JSX really is. It is syntactical sugar in JavaScript, where we allow a custom version of the JavaScript language to be transpiled into a version of the JavaScript syntax which is supported in browsers. So if we look at this example here, this HTML-like syntax of a div, that's not actually going to run in the browser, but it does get transpiled to something that will run. And this div execution over here is basically a call to the JSX runtime. And in this case, we're going to create a div with no properties. If I were to add something over here, like class name is moo, then we can see that the class name prop was in there. If we were to add a child in here, we can see we have a children's prop. This is JSX if you want, and in ReScript we have to do the same thing. We have to eventually get our code to be transformed into this JSX runtime kind of calls, which is what we're going to touch upon in this video. We're going to create a new ReScript application using ReScript app. So I can do bun create ReScript app. I always put an at next, but this actually should be fine. So what this does is it gives you a little wizard. Explain, let's do for explain JSX. I'm gonna take the V template because it comes with React and going with the latest beta. Everything in this video will be tailored towards ReScript 12. Most will apply to 11 as well, but just keep in mind that everything I do talk about will be with version 12 in mind. When we open this newly scaffolded project inside our IDE, what we get is a package JSON with all our dependencies. So we're going to use ReScript React for the bindings. We need React itself, React DOM. We need the ReScript compiler. This is all more or less what you expect. And then we have like Vite and Tailwind and some other goodies. Our ReScript JSON will have a couple of configurations required and tailored towards JSX. So first off, we need to list our dependency. This is a ReScript dependency if you want. Then we have a node JSX where we do version 4. And this actually hints at the PPX, internal PPX transformation. A PPX is like a thing that modifies your source code based on the AST level. It's an OCaml plugin if you want. And if we enable this, it will have transform our own code with React specific things to different ReScript code. And then eventually it can transpile or compile if you want to JavaScript. Without this, our JSX syntax will not work, and this version 4 really means the fourth iteration of the JSX internal PPX plugin. You don't overly have to worry about what a PPX is, but I will touch upon it later in this video to really explain to you what it is actually doing. So I'm starting the ReScript compiler in watch mode, and I'm going to add a new file to my source directory. How is this going to be picked up? Reminder. We have our sources over here, we have the source directory. So if I add a new file over here, let's say Greeting.res, then it will be compiled and we can see what this does. Currently, it's an empty file. And if we were to add an initial snippet over here, let's start with dissecting what is a React component. So in essence, what we actually want is the JSX call, the JSX runtime, and there are bindings in that for because of the ReScript React package that we have a dependency on. So a component is nothing more than a function that takes in a record. So in this case, we're using a record props here, which we constructed ourselves, and it returns a React element. So if I were to type this React element, then we can see that this is really the definition of a component, and that component can be passed through our JSX runtime. So we see here we have the JSX runtime. We are using JSX syntax to create a div. This is being transformed. We'll talk about that a bit later. But for our own invocation, we have JSX runtime call as if we were to write it by hand more manually, more or less. So this is what we want. We want that JSX runtime call, but of course we want the syntactical sugar that JSX provides. The trick here is to call our component function make, literally the word make. It's like a convention. Any make function in a module can be used as JSX syntax. So this to over here will actually be an invocation of a JSX runtime with the function make. And the reason this compiles over here is only because it is make. If it were to be make2, then we can initially see that, oh, there is no make in module 2. And then it says hint make2, but you can't put it there. Like the JSX transformation only applies when it is called, function is called make. To further illustrate what actually happened here, I can invoke the compiler in a debug state to reprint the transformation that happened with this ppx thing. So remember, our syntax here, our ReScript syntax, will be transformed by the ppx. So I can actually just invoke the BSC compiler. So I think that stands for buckle script back from the earlier days, but when you call ReScript, you're actually calling a build tool, and the buckle script compiler, well, it's just a ReScript compiler really. That's what's happening when you do BSC. We are now saying that apply the transformation, the internal ppx. So you notice that this 4 matches version 4 of our ReScript JSON. So that's that. And then we can say, okay, we only want to parse the code. So this is just parsing the AST. And then we want to reprint the source of this greeting. And when I execute it, you'll see that module 2 is actually transforming the make, the JSX div over here, to React DOM JSX. And the 2 invocation was changed to React JSX, which is again ReScript code. So this is the binding, and it passes in our make function as the component, and then these are actually the props which it received. So it took these things and created the record props over here. Notice that my div is slightly different than my own component. So I have React DOM JSX and I have React JSX over here, and basically any lowercase component is considered to be like a DOM element. So if we were to do just like a foo, you'll see over here that we are just doing the same JSX runtime foo. And if we run this command again, we're just assuming it's a DOM element. This is a bit of a trade-off, so it's not going to check if it's an actual existing DOM element. But the moment you start using something like a web component, this is totally valid, and then the compiler can still do the right thing over here. And that's why it's a bit of a convention. Anything lowercase will be just a DOM element and passed into JSX runtime, where the tag name is just a string. In the next example, I want to take a look at what the React component attribute does. So in the other example, we created our props record by hand. But if we use names parameters with a tilde, these can also be transformed into like a record type, and that record type instance can then be passed. So if we were to check what happens with module 3, you can see here that a props type was created. In this case, it's generic because, well, I don't really know why it's generic. It probably has a good reason. Probably is most flexible. And then the make function is actually being a destructured version of my props. So instead of the tilde title over here, it became an instance of a record. And then everything happens and plays out as you already had. But the thing here is that our make function is also being shadowed, and the make function will be shadowed by a uppercase identifier. And this is interesting for React tooling, because what this leads to is a function with an uppercase name over here. And a lot of tooling just depends on that. Like a function definition, like a component definition is just meant to be uppercase. So this is what that @React component does. Another benefit of the React component attribute is that if you have no props at all, you still need to pass in an empty record. So putting this annotation over here, if we take a look at the transformation again, it will still create that empty props type record, and you don't need to pass it along. Okay, and then as a last example, there's also something called component with props, where you do define your own props records. You would do this when you want to have control over the props record, but also want to have that uppercase name. So if we then scroll into our compiled code, we can see greetings, which is the file name module $5. So that corresponds to that. And because of this attribute, we have that. If I were to change this, you can see that it becomes make, but the lowercase make. This is a recent addition. This is part of V12. My advice here is always to use a React attribute, either React component or component with props. And that's because tooling just expects React components to start with an uppercase name. In the next example, I want to talk a little bit about JSX elements and JSX props. So I have another module here with a React component. It has a handler, an optional title, and a count. Notice that all these are having an actual type, that the usage can be inferred by ReScript. So we have a count here, but we're doing a +1. So it figures out that, oh, count must be an int. We have a handler over here that takes that int and returns units, because the onClick is expected to return units. The onClick takes a React event mouse. Again, these are your React bindings. When we have a property name that's the same as our value that we want to pass, we can do something called property punning. And this is equivalent to passing onClick to onClick. In this case, we note we marked our title as optional, so we can't just directly use it. This is an option of string, and we're going to use a switch here. We have none, and if we want to like not show anything or just pass in NLL to React, we can use the React null binding. So it always, a child needs to return a React element. And in the case of a string is not a React element, so we can use the React string helper, convert it, cast it into a React element. In this case, I constructed properties. So again, because we have React component, there is going to be a props type in this module. We can see that a type props was created over here. So we can create an instance of this prop and then do property spreading. And in this case, I'm going to spread my props. I do need to do it first. And then later I'm going to override the title. So if I were to do it like this, I'll get a warning. And it says like multiple spreads are not allowed. So it is a little bit confused, but I can only do a spread over here when I pass it as the first prop argument in my JSX syntax. So if we take a little bit of a look what happens with a spread over here, we'll see that what actually happens is we're gonna spread my props and then change the title and then pass that into React with the component function that we had. So that's more or less what you expect. And if we take a look at the compiled code, you'll see that it is using my button over here. This is a little bit of older, I guess, JavaScript syntax. So what this does is just first update new record and then basically returns new record with this comma. So for optional props, we can pass them with a question mark, but of course we need to ensure that the prop name matches, so we can use punning. But we can't really assign an expression to this directly. So if I were to try and put in some else, like that's not going to work just on a syntax level. Like when you want to do the question mark property, you're expected to just pass it as a punt property as well. Let's now talk about children in ReScript JSX. Children are the most weirdest choice, I think, when it comes to the difference between regular JSX and what happens in ReScript. Children can be a single identifier over here of the type React element and just fit in to the JSX syntax. So if I were to have something like some element, which is break, I can just put it in my container and that actually works. I can't really do anything else. So if I were to put in a string over here, then I just need to wrap it in a React.string to do the conversion, and the expression over here will be evaluated. So I can put an expression between curly braces, but the only thing that I can do without curly braces is actually just pass in an already existing identifier, which is like a single word typically of React.element. So if I want to put in a number, I need to convert that to an integer, same for float. If I want to use an array, for example, here we're doing a mapping to get list items, and this array.map will return an array of React element. And even that is not good enough. That needs to be cast to a single React element, as you can see in this helper function. So this is, I don't know, this is the more weird thing about ReScript and JSX. And if this bothers you as well, just please leave a comment on the video just so I know that I'm not alone. And thank you for your support. Who knows, maybe one day we will tackle this. I also want to take a brief moment and talk about external components. So these are components that you might have from a Node module and don't own the definition. What we can do is with the external binding, just point it to a certain module. We can use the React component, but this is only going to work when you have named parameters. So if you take a look, we have React Confetti from React Confetti. It is the JSX runtime call, and it converted the props into an object, so that all worked. But if we want to have an external binding and type out the props type as a record, what we can do over here, so I have some map props that use some stuff like I defined above. If I then want to use the props records that I defined here in my external binding, I need to use React components, colon. So this is also something I found very puzzling. Why is the colon there? What does it mean? But it's just syntax really. So there's a colon. And if you then have your type, then that will be accepted as the transformation of your make function, and you know that will work. So we can see that we have React map, we have mapbox, and it's being passed down with the props that we web provided. But this needs the colon because otherwise it just doesn't know what it is. Not to be confused with React component with props. When you want to use an external binding and this attribute, it's a no-go. You should do the other thing, React component, and use the colon and then your type. So there's still more to cover when it comes to ReScript and React, but to wrap up the video, I want to show something other that's rather cool in ReScript 12. Instead of creating the JSX runtime calls, ReScript can also just output JSX. So if we go to our ReScript JSON and we put in preserve true, so let's just change the file so it recompiles. Then you can see that now we have experimental JSX support. This works pretty well, but there's a bit of a catch that you need to use React component or component with props for this to properly work. There's one little edge case when if you were just use a straight up make function without the attributes, then it's not going to produce the correct JSX. But this is extremely useful for something like the React compiler because that expects JSX input. And this is a welcome addition that's hopefully going to be more polished in the future, but definitely try it out if you're on version 12 and have the opportunity. If you want to see more of this type of content, please let me know in the comments, leave a like on the video, and until we meet again.